Recording has begun. Welcome to the study hall for June 6th, 2013. Today's topic is the C trap in data sufficiency, where if you don't know what that is, you will very soon. Welcome back. So here is the usual disclaimer about it's not a disclaimer, the usual acknowledgement of the source of the problems, except as indicated. These problems are from the gmatprep software. gmatprep software, not the official guide. So that is free software that is free to distribute. And so we can also use those problems here in the session. Remember that official guide problems, on the other hand, we cannot use. So any problem whose source is not attributed is from the official guide, or from the gmatprep software, and is copyright GMAT. Is the obligatory acknowledgement. Okay, let's try this problem right here. And remember where to find those multiple choice answers. Please do not type your answers to multiple choice questions in the chat box. Instead, please use the multiple choice answers that are located where we showed you before. And that is right there. Okay, I'll put a timer on this one and we will get going. Okay, ladies and gentlemen, that's time. About 20 or so of you have picked answers. There's 35 of you here. So remember how the GMAT works. This is not the kind of test where you can not pick things. Like, you always have to pick something on every question. Because remember, you have to answer all the problems. So if you have not selected an answer yet, please do so. You can wait about 5 or 10 more seconds for that. And while you're picking your answer, I don't know if you guys all were here in enough time to see the title screen, but you can probably guess, based on the title of today's study hall, or title of today's study hall, you can probably guess that C is not the answer to this problem. So, but about 8 or 9 of you went ahead and picked C anyway, so there it is. But okay, let's talk about this one right here. So here's the problem. And here are your responses. So again, we had a lot of people picking C. I mean, the one thing you're going to notice in today's session is that the answers to today's problems, folks, are not going to be C. I mean, this will become manifestly clear to you as soon as you see what the theme of today's session is. But let's talk about this problem. So if m and n are positive integers and r is the remainder when this expression is divided by 3, what is the value of r? Just a second, please. All right, so let's talk about this problem. But before we talk about it, let's just before we talk about how to solve the problem, let's talk about what they do and don't do here, and what kinds of answers are not going to be the answer to a problem like this. So the thing with data sufficiency, like, what are they really trying to test when it comes to data sufficiency is the idea that we want to understand here. And if you get like what they're really going for in these problems, like if you get what they are actually trying to test for here, then it will be easier to understand this type of trap answer that we're talking about. Like what's really being tested in these problems. what you're going to notice is that one of the main things that they're actually trying to test in these problems is focus, which means, do you have a goal? Like, do you actually have a thing that you are trying to solve for? Are you trying to solve for something specific? And then if you do, can you stay focused on it? So, I mean, this seems humble. I mean, this seems like a very first grade type of thing to be testing. But it's really what they're after here. I mean, data sufficiency is not so much a test of math. In fact, one thing you will notice is that a lot of the mathematics in data sufficiency problems is pretty basic. Because what they're really trying to see here is this, like, can you have a thing that you are trying to solve for, and can you keep your mind focused on that thing? So, in this case, what do we want? Like, we want the remainder of this division. What do we not want? Let me know where I'm going with that. Like, what things in this problem do we not really care about? Couple of people are typing. Yeah, we don't really care about what the value of m or n individually is. We just care about the remainder. The goal of this problem is to find the remainder. I mean, this should seem like a very basic fact, because I mean, it is a basic fact. Like, okay guys, what are we solving for? Well, here's the thing that we're solving for. I mean, this is a pretty basic fact. But what I want to point out is the flip side of this fact, which is that solving for everything in the problem, in other words, the individual values of m and n, is not the goal. That's not the point here. So, and I mean, when you do data sufficiency problems, this is the first thing that you really need to be thinking about, is like, what are they going to have me do here? What they're going to have you do is they're going to give you a situation, especially if you are scoring at decently high levels on this thing. They're going to be giving you situations where you find basically exactly the stuff that you're looking for, and you don't really find other stuff. So, what I'm looking to do today is first we're going to teach you how a certain type of trap answer works, but also I want to build a set of expectations in your mind when you see data sufficiency questions like this, so that you kind of have this advantage of knowing already what they're going to do here. So what you should expect two things. The first thing you should expect is that you're going to find that thing that you actually want to find with some combination of the statements. But, and this is the really important point here, you should expect not to find everything. And this is where a lot of people get burned over and over again on data sufficiency, is they keep trying to find all the stuff in the problem. So, it's quite the opposite. In fact, when you leave today's session, you should have this instinct that is exactly the opposite of that. In fact, your instinct that you should have by the time we're done with today's session, is if you actually find everything in the problem, especially with choice C, you are probably wrong. This is the big thing, and we're going to see specifically how this whole C trap scheme works out here. But if you wind up with all the stuff that is in the problem, then something is probably very, very wrong with that. So we'll discuss how this problem works in a second, and then after we do that, we'll talk about why you don't really pick the C here. If anybody has any questions so far, go ahead and type them in the box. If not, we will go with a quick discussion of how to solve the problem. But this is the big thing. This is today's repeating theme. So why are you discarding the C option is exactly what we're going to be getting into here in a second. But first, let's talk about how to actually solve the problem. And then we will generalize about stuff like that. So here's the problem. Let's make a new screen. Okay, so first let's just solve the problem. Let's just see how it actually works. So, and remember, this is in previous sessions too, but when you start approaching a data sufficiency problem, you should always do the same thing first, which is get exactly what sufficient and not sufficient mean. So here, sufficient would mean what, and insufficient would mean what. Like, what does sufficient mean here? You may want to type in the chat box. Specifically, what does it mean if you get sufficient for this problem? Or what does it mean if you get not sufficient for this problem? Discrete value, I think you mean like a single value when you say that. Yeah, unique value, right. There's only, sufficient would mean there's only one possible value of the remainder. And then, so not sufficient would mean that there are two or more possible values of the remainder. And remember to stay focused on the goal here. I mean, you don't just want to say one number or just like one value, period. You want to make sure that you are focused on the thing that you need to focus on, which is the remainder. So this is the point. Okay, so statement 1, let's take a look at that. So if statement 1 is there, then that means that n is 10. So n equals 10. That means that we have 5 times 10 to the 10 plus m. So what is the remainder when 5 times 10 to the 10 plus m is divided by 3? So, I mean, if you want to think about what this number actually is in terms of size, you can, or you can just kind of think about the fact that you can still make m pretty much anything you want. I mean, if it helps you to think of 10 to the 10th as being 10 billion, then you can do that if you want. If it doesn't help you, then you don't have to. But what is the remainder, if you want to think in those terms? What is the remainder when 50 billion plus m is divided by 3? So if you know how remainders work, it's pretty clear to see here that you can get more than one possibility, because you know how remainders work, right? Like they keep going in cycles, like 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. So even with numbers as large as 50 billion, I mean, if you just consider the first 3 instances here, if you have 50 billion plus 1, or if you have 50 billion plus 2, 50 billion plus 3, these are all going to give you different remainders when you do this division. I mean, in some order, the remainders are going to be 0, 1, 2. So these will all give different remainders on division by 3. Okay. If there are any questions about that, please go ahead and type in the chat box. Someone wrote M question mark. I'm not sure exactly what that means. I mean, M is a variable that's in the problem. So just check it out. If you have any other questions in that vein, then go ahead. But so statement 1 is not sufficient because you can get multiple remainders. Okay, now let's talk about statement 2. And let's take some of this stuff over to the next page in order to do that. So can we reduce the problem? I mean, I'm open to that idea. Do you have any ways that you're suggesting that you could do that? If you do, then go ahead and type in the box, and we'll talk about it. I mean, remember that you shouldn't, like, kill yourself trying to rephrase problems. Like, if you see a really obvious way to rephrase a question, to simplify it or something like that, then go ahead. But if it's not immediately forthcoming, it's not really a big deal. I mean, like 95% of data sufficiency questions, you're going to solve the question in exactly the way it's presented. In fact, doing too much rephrasing is a very risky thing, because if you rephrase things into any form that is not exactly equivalent to the original, then you're going to be in big trouble. Distribute it to... you wouldn't want to distribute it like that, because remember, we're talking about remainders. And if you do anything like that, then the whole idea of remainder is not really going to work anymore. After we're finished with the problem, I can show you what I mean by that with another couple of examples. But yeah, if we were doing just normal division, then you could do that. But with remainders, it's not going to fly. And we'll talk about why not shortly. Okay, so let's do statement 2 here. And there are whole sessions on this kind of thing, so you can watch the recordings of those if you don't really know 100% what's going on here. But let's look at this statement in 2 different ways. The 2 primary ways of approaching data sufficiency problems. See if you guys know what those are. One approach is to use theory, of course, like algebra or whatever else you want to call it. What's the other main approach? Like, if you don't see a way to approach a data sufficiency problem using theory, what should you immediately start doing? You should start plugging in cases. So, I mean, again, if there's one thing, honestly, folks, if there's one thing you guys get from these sessions when it comes to quant, it's like testing cases in data sufficiency. Huge thing. Like, you'll get up to 10 chances to do that on one official GMAT. So, it's like the one thing you definitely want to know how to do here. So let's do that first, actually. So let's test cases. And remember what testing cases involves. If it turns out the same way every single time, then that's sufficient, as we set up here. And if you get 2 different things to happen, then it's not sufficient. So we want, which one is preferable? The answer is you want both. You want to be able to do these problems in as many ways as you can. I mean, if you don't want to start calling them preferable, is the point. Like, if you start making some hierarchy or you start trying to rank these things, not a good thing, because what all that's going to do is make you not want to do the things that are lower in your hierarchy. Not great. Okay, let's test cases here. So, I mean, m is fixed at 1, so we get to pick values of n. And then that's 5 times 10 to the m plus 1 is the number that we're concerned with. And then we want the remainder when we divide by 3. So there's a nice little table. When you test cases, it helps to make tables like this just to keep your thoughts organized and so that you don't forget what the steps are. It sounds stupid, but it's very, very easy to, like, totally forget what it was that you were doing right in the middle of it, especially when you're under the pressure of this kind of test. So, all right, well, might as well start with 1. And then, you know, let's try the first few cases. Well, that's 5 times 10 plus 1. 51 divided by 3 is 17, is no remainder. So, if you have 2, then it's 501. If you divide 501 by 3, it goes in 167 times, and it leaves you no remainder. If you have 3, 5001, if you divide 3 into that, I think it's 1667 times, and you still get no remainder. 50,001, it'll go in 16,667 times, and there's no remainder. And I mean, there's clearly a pattern here. I mean, if you actually do the long divisions, even the quotients have like a really obvious pattern. It's like you have 17, 167, 1667, 16667. The next quotient will be 16667. So the same thing is going to keep happening forever and ever and ever. Amen here. So you're going to get one remainder over and over and over again. So this thing is sufficient. Not going to get any other remainders there. Any questions about that? So that's a way. Again, this way is not better than using theory. It's also not worse. It's just a way. And the point here is to have as many ways as you can. Does anybody have a theory approach here? If you do, just chat it. Shy crowd today. Five plus one. I mean, ln2, are you talking about the digits, maybe? Looks like you're trying to use a digit rule, yeah. Right, you guys are starting to talk about there's this divisibility thingy going on. So let's do that, right? If you have 5 times 10 to the n plus 1, if you have a number of that form, then its digits will always be a 5 at the beginning, a 1 at the end, and then the rest are zeros. So, and there's this thing with divisibility by 3, which is that if you add up the digits, then the remainder is going to be the same as it would be of the original number. So instead of actually dividing 50,001 or whatever by 3, you can just add the 5 and the 1 and the zeros. So the sum of the digits will always be 6. So 6 is divisible by 3. The principle here is if the sum of the digits is divisible by 3, then so is the original number. It's in our number properties guide. It's also a thing you can figure out by just playing around with numbers and watching what they do. But what the upshot here is that the number is always divisible by 3. So there won't be a remainder. Remainder will be 0. That's sufficient. And I mean, you might be like, whoa, what if I don't know this divisibility rule? And that's the reason why you want to have a diversity of approaches here. Because if you don't know how to test cases, then you will actually have to know how this divisibility rule works. It's a good thing to know, but again, the fewer approaches you have, the more stuff you'll have to know. But if you don't know this, or if you just forget it, or if you just blank out, or whatever, then you can just start throwing cases in there and everybody's happy. So, okay, any questions about how to solve the problem? Because we're going to get into the C-trap stuff here in a second. But first of all, are there any questions about how to actually solve the problem? The remainder when divided into the sum of yes, Kevin, that is how it works. Any other questions? A couple people appear to be typing, but they stopped. Okay, so now let's talk about people, because I mean, some of you guys picked C, about 8 or 9 of you did. I mean, some of you judiciously changed your answer after that little scolding we had getting. But let's say you picked C here, which probably a third of everybody here did at first. Let's say you picked C here. How would that work? I mean, C is the wrong answer. The answer to this problem is B. Just to make sure we have it on the table, the correct answer is B. So, and I mean, what that means, among other things, is that you don't ever actually combine the statements. Because remember how data sufficiency works, right? You don't actually put the statements together unless they are individually not sufficient. So we don't even have to deal with the whole C thing. What we're getting at here is that you should look at this problem and already know that it's not going to be C, and we're going to talk about why. So if you pick C here, here's how that would work. You'd have a value for M and a value for N. In other words, you're just given everything. You're just handed everything in the problem. So then 5 times 10 to the n plus 3 would just be a number. And so therefore, you wouldn't even have to do the math, because you just know already there's only one outcome. Do you guys think a data sufficiency problem is going to work like that? What do you think? It's not just this problem. This is a very general thing that we see on this test. So, like, let's generalize about what's going on here. Too easy, yeah. I mean, that's the first thing. Too easy. You're just given everything. So it's too easy. There's no work. Easy but tricky, Vijay Akashik. What do you mean tricky? Because like, the thing if you pick C here is that you're totally not being tricky about things. You're just being like, oh, they gave me all the stuff. So maybe you can explain what you mean by tricky there. But the first aspect of this is that it's too easy. There's no work to do at all, right? You're just handed stuff. And then just as importantly, you are handed way too much information. That's another key aspect here. Too much information. Because remember, the focus is just the remainder. It's not everything. So if you do get everything, you should be strongly suspicious of that. And then probably what's most important here is this. This is a problem about remainders. So it's going to sound really obvious when I put it in these terms, but folks, if you get a problem about remainders and you don't have to think about remainders, probably not a good thing. So you don't even have to think about the key math concept. These are the 3 trademark aspects of what we refer to as a C trap. Like if you ever see a problem where choice C has all 3 of these traits, basically you should just not pick it. There you go. So let's generalize here. If choice C does all 3 of these things, if it is too easy, if it gives you too much information, like in other words, much more than, like you get everything in the problem instead of your focus, and then if it doesn't use the key math concept in the problem, then don't pick it. It's a trap. So, I mean, okay, if you, as a disclaimer here, I don't think anybody who attends these study halls usually fits this profile. But as a disclaimer, if you are scoring very low on the quant section, then you may get things that work like this that really are C. But if you are not, as long as you're not scoring quant, you know, like 20 or so, or 25 or less, then if you see something like this happening, it's there as a trap. It's there to try to snare you. Yeah, too easy, and then you can just plug in and get the answer. Exactly. Now, make sure that you guys don't overextend the concept of too easy here. Like, when we present this to people in lessons and stuff, sometimes they just take that ball and run way too far with it. And what I mean is, you know, they'll be like, oh, after I do these 8 lines of work, this is really obvious, and so it's too easy. No. Like, too easy means no work has to be done at all. Like, you can just add things or you can just plug in. If you do any non-trivial mathematics or algebra or reasoning, then that's not too easy anymore. Too easy is like this. Dude, here's a number. Here's another number. You can just throw them in there and it's a number. So these are the 3 key aspects of what we're referring to as a C-trap. Any questions about that? And what's cool about problems like this is that you can get rid of C, but you can also get rid of E. Because it's for different reasons. You're getting rid of C not because C is unreasonable, but because you know it's a trap. That's how they make trap answers. But you can also get rid of choice E because it's impossible. I mean, remember what choice E means. Choice E means even with both statements, you still cannot solve the problem. And I mean, the whole point here is that it's super easy to solve the problem if you have both statements. It's so easy that you're suspicious of it. So it's definitely not E. Like E in this problem would mean even if I give you a number, you still don't know what the remainder is when you divide it by 3, which is, of course, not a thing. Any questions about this? So this is the basic idea of a C trap. We're going to see a few more problems where this is a thing. Okay, let's try this. Right here. Go for it. I'm going to clear out your answers. Remember where to get multiple choice answers. That is where you're going to get those, ladies and gentlemen. Okay. Here's a timer. It's a word problem, so I'll give you a little bit more time. And have fun. So there are at least 2 people who have picked C here. I mean, maybe you guys just got here, but if you didn't, remember what the theme of today's session is. So keep that in mind. Okay, so we only have the answers from about half the people who are here right now. So please pick something in the next, I don't know, 5, 10 seconds if you haven't already. And remember, people, the theme of today is problems where C is a trap. So the number of people picking C and E on these things would be nobody. All right, so here's what we have. I mean, remember what, I mean, I suppose it's possible that there are 7 people who weren't here for the last slide. Actually, it's not possible because I can see how many people are in the room. But I mean, folks, remember, okay, here's the thing from the last slide. I mean, we're not kidding about this. So, in these situations, we're talking about situations where you get rid of C and you get rid of E. And yet, if you look at our results here, we still have 7 people who have picked either C or E. Which, I mean, maybe it means I'm just not communicating effectively today or something. But boys and girls, ladies and gentlemen, you should not be picking these 2 answers. Because that's the theme of today's session, is things where those are wrong. So keep that in mind. Shouldn't be picking those. All right, so. All right, well, let's talk about it. So before we actually solve the problem, let's talk about why this is a C-trap problem. Like, remember our 3 criteria for making something a C-trap? Here they are. If choice C is too easy, gives too much information, and doesn't use the key concept, don't pick it, it's a trap. Well, let's see if this satisfies all of these. So, well, you have this fact, right? You have this fact about the difference between these 2 was twice the difference between these 2, and hers is the highest. If you pick C here, then you have numbers for Jim and Kate, which would mean you could just find Mary, because Mary's would have to be twice as far away from 30 as from 40, which means it would have to be 50. So it's too easy because you just get the numbers for all 3 salaries if you just in basic arithmetic for Mary. It's too much information, right? Because remember, the focus here is not all 3 salaries. It's just the average or arithmetic mean of the 3 salaries. Not all of them. And again, the thing I want you to come away from this whole presentation with is, in a problem like this, again, presupposing that you don't have a quant score of, say, 25 or less. If you do, then a lot of the things that would otherwise be traps might not be traps. That's the disclaimer. But as long as you are scoring decently or better in the quant section, you should take this principle to heart here. If you get all the stuff in this problem, you're almost certainly wrong. Because that's what they're doing in data sufficiency. That's actually the entire thing that animates these problems. They want to make sure that you can focus on a thing. And if they gave you a problem where you actually did wind up with all the information, then you would not need to focus on anything. I mean, you would just find all the stuff. So they specifically engineer these so that if you are not focused, you will get them wrong. That's the point. So, and then finally, if you just have 3 numbers, then you don't need to worry about an arithmetic mean because, well, you would have all the numbers. So it satisfies all 3 criteria. If you have all 3 numbers, then you simply don't have to worry about the arithmetic mean. So you don't have to think about it, how averages work. So this is not going to be C, and also it's definitely not going to be E, because if you have 3 numbers, then of course you could answer this question. So, is it okay to draw rough outlines in the rough sheet provided? I mean, is it okay? What do you mean, is it okay? I mean, you can draw whatever you want to draw, and you should draw whatever you want to draw. Whatever gets your brain moving, man, you should draw. I mean, it doesn't matter what it is. It's a very individual thing. I mean, some people even think better when they doodle on the corners of the paper. You want to do that if that works for you. But it's all a matter of playing around with stuff and seeing what works for you personally and what doesn't. So now let's actually solve this problem. But if you guys give me a smiley face if you understand this whole thing being a C trap. And again, remember the smiley faces are in that underneath your name up there. Okay. Yeah, sweet. Okay. So now it's actually solved the problem. But we have this advantage of knowing that, you know, it's not going to be C or E. So, Kristen, yeah, because it still could be A or B or D, right? You just have to solve the problem. I mean, there'll be some instances where you where one of the statements will be super easy and you'll basically be done. But you will have to do work. So, all right. Well, the difference between Mary's and Jim's, they seem like parallel answers. Hey, let's pause here for a second to talk about this. I was hoping somebody would go there. What do you think you should expect in that kind of situation? Like, whoa, statement 1 looks just like statement 2. What do you think they're doing there? See what you guys say. I mean, yeah, it could be either one or neither. It could be either or neither. That is all the possibilities. Okay. Yeah, Angelica, don't know quite how to pronounce it, is going where I want you guys to be going here. Like, okay, like it's sort of like growing up and learning how people are with sarcasm and trickery and stuff like that. Like when you're a little kid, you think that everybody means exactly what they say. And then as you get older and hopefully wiser, you learn that this is not the case anymore. And this is sort of like growing up in the world of the GMAT, where if you are like a small child in GMAT terms, you'll be like, oh, they look the same, so they will act the same. And you'll pick D, and surprise, surprise, you will be wrong. If you grow up in the world of the GMAT, you will look at something like this and be like, aha, those look a lot like each other, so I bet they do not act the same. So you should think, hey, those look alike. Which probably means that they do not act alike. I mean, in this sense, the data sufficiencies in this sense are almost like your sort of rebellious teenager where they're so unpredictable that they just become predictable. Like, you know, if you tell them to go left, they're going to go right. It's kind of how they roll, right? To the point where if you want them to go right, you can just say, hey, go left, and they'll go right. It's like that. I mean, in these kinds of things, if you get symmetrical looking statements, the likelihood that both of them work in the same way is extremely slim. Because that's how they make these problems. They want these to be different in some sort of way. So, Chris, I'm glad you brought that up, and that's an instinct that, because as you can see, there's more to this stuff than just solving the problems. I mean, there's this whole, okay, now I'm learning how they roll. And I'm learning how they make the problems and don't make the problems. That's what you need to be thinking about when you look at these kinds of things. All right, so let's take a look at these statements. Someone in the chat box has posted an official guide reference, so thank you for that. I can't post it on the board because it's an official guide, but you guys, if you see that reference in the chat box, you may want to write that down. Go look it up later. So if Mary's annual salary was the highest, what was the average arithmetic mean? So let's take a look at statement 1 here. And let's test cases. You don't have to test cases, but again, I want to shove testing cases reasonably far down your throats. So let's test cases. So Jim's salary was 30. We don't really need the thousands. We can just write 30. So Jim, Kate, and then Mary was the top one. And then, all right, so if Jim made 30,000, let's say Kate made 50,000, then the difference between Mary and Jim would have to be twice the difference here. The difference here is 20, which means the difference between Mary and Jim would have to be 40. So Mary has to make 70. And then the average of those three numbers is 50. All right, Jim still has to make 30. Now let's say Kate makes 100,000. So the difference here now is 70, which means the difference here would have to be 140. So Mary's got to make 170, and the average is now a lot more than 50. I mean, it's 100, but you don't have to calculate that because the point is that there are two different outcomes. It's not sufficient. Don't waste your time calculating if you notice that it's not 50. Okay. So statement 1's not sufficient. Incidentally, if you see the C-trap nature of this problem, at this point we're basically done. Because like here's the grid that we have in our materials, right? And we just got rid of A and D. But then we are, you know, C and E are in trap land. So you kind of already know that this is B. But nevertheless, let's go ahead and run a table of values here and see how it goes. So statement 2, let's just use the same table that's already up there. So this time Kate has to be 40. So Kate is 40 forever. All right, well, if Jim made 30, then the difference is 10. So the difference between Mary and Jim would have to be 20. So Mary would have to make 50. The average is 40. If Jim made no money at all, then the difference there is 40. So the difference between Jim and Mary would have to be 80. So Mary would have to make 80. In that case, your average is still 40. If Jim made 10, then Mary would have to make 70. Okay, I think I see where this is going. If I'm an extreme skeptic here, I might want to try one case of an ugly number. Let's say like 14, which is actually a very beautiful number. Then the difference here is 26, which means the difference would have to be 52. 14 plus 52 is 66. And if we have that, still an average of 40. So we're getting 40 forever. Sufficient. So make sure you can do that. You can do this with algebraic quantities and stuff too, but you'd be juggling a lot of interesting variables and stuff there. This is probably this is the simpler way to do it. Again, you want to be able to do it in as many ways as you can. Make sure that you can do it like this. But more germane to the theme of today, make sure you take a look at this and are like, hey man, that is totally not C. Any questions about this one, go ahead and type in the chat box. If not, we will move on to another problem. Okay. Move on to another problem. How did you know not to simplify the equation of the problem? I mean, you don't know that. Although, I mean, you can try to simplify it if you want to. You know, take a crack at it, see how it goes. I mean, basically, you should just try whatever you think of trying. I mean, the thing with testing cases, I don't know why I wrote statement 3. Geez. The thing with testing cases is that you normally shouldn't simplify stuff too much. It's kind of the whole point of testing cases, is that you can use the statements exactly as they are given. So The danger, again, with trying to simplify or rephrase or do whatever to this stuff is that you can make mistakes in doing it. So with testing cases, it's better to just kind of stick with the information they give you, unless the simplification is something that is completely obvious to everyone. So yeah, I mean, hopefully that helps. But if you want to try doing it, of course you can. But if it is not immediately forthcoming, then do not keep hacking at it. Instead, just use it the way it's given to you. Because again, focus is the point. I mean, you don't want to try messing around with these things too much, because the whole point is there's a focus that you need to retain. Kai Chirag, I don't really know how to say that name. I mean, it doesn't matter if it's slower. Like, it's none of these things are that much work. I mean, if you look at this, this is not more than, say, 30 seconds of work. So don't worry about which ones are slower. You just need to be, you need to have as many approaches as you can have. You should never be like, oh, slower or faster. You should just have lots and lots and lots and lots of ways to do these things. All right, let's try this problem. Go for it. It's a shorter problem. It doesn't mean it's easier. It just means that it's shorter. So we'll give you less time. So how about that much time? Okay, go for it. And don't forget what's not going to be the answer. Okay. Remember to pick something, please. The way this test works, you're not allowed to not pick stuff. So, very interesting answer profile here from you guys. We have almost exactly even numbers of people picking. Someone just switched to C. Remember the topic today, folks. Yeah. We get almost identical numbers of people here picking each of A, B, and D, which means that the problem is definitely going to be something interesting. But okay, first let's talk about this whole trap nature of the problem. So if it is too easy, gives too much information, and doesn't use the key math concepts, well, let's see if this problem satisfies these things. So again, first, what's the focus, people? Well, the focus is this yes or no inequality. The focus is not what. Like, what are we not trying to find here, and what should you specifically expect that you will not find? Chat box. You should not expect to find values for x and y, and something is very wrong in Dallas if you find them. So the focus is not on the individual values of x and y. And if you get individual values of x and y, you're probably wrong. And I mean, one thing, the one thing I want you to notice about this is what's interesting about data sufficiency is that a lot of people get problems wrong before they even start working the problem. Like in multiple choice, that's not a thing. I mean, if you get something wrong in multiple choice, it's because you made some mistake along the way or you got stuck somewhere in the problem. But what's interesting about data sufficiency is that you can totally get these problems wrong before you even start them. Like if you look at this problem and think, I want to find x and y, like as soon as that thought enters your brain, you are already wrong before your pen even touches the paper. Like if your thought process is I need to find x and y here, you cannot get this problem correct because that's not the focus of it. The focus is to not find x and y, but to still find the inequality as a yes or no. So this is super, super important. I mean, if you don't have the right focus at the beginning, you're dead, and there's not a lot you can do about it. So, but, okay, let's consider choice C here. I mean, if you have choice C, everything is numbered. You know, it would just be, is 8 plus 20 greater than 8 minus 20. I mean, that would be sort of weird, right? It's too much information because, yeah, it is too much information. I mean, you get everything in the problem, which is the values of x and y, rather than just what you want. And then finally, it doesn't use the key concepts. I mean, you don't have to manipulate inequalities at all, or even think about inequalities, because everything is numbers. So this is a classic C-trap type of situation. Do not, for the love of everything that is good in this planet, do not pick C and do not pick E. So, any questions about that? Okay, so now let's actually solve the problem. Boom, 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 solve the problem. So let's take a look. Well, statement 1. So what we should do is substitute that into both of those things. So if 8 minus y is less than 10, is 8 minus y greater than 8 plus y? So Kristen, you were asking about simplifying stuff before. Now this is the kind of thing that you definitely want to try to simplify because it's like an algebraic inequality that has really obvious algebra that you could do. That you can get rid of the 8 and you can also add the y to both sides. So that, I mean, if it's clear that there are simplifying steps that you can take, then you should, of course, take them. But you shouldn't try super hard to simplify stuff. If it's not immediate, then don't worry about it. So, is 0 greater than 2y, which is the same thing as saying is y negative. Okay. And then we can also play around with that one too. Minus y is greater than 2, which means that y is actually less than negative 2. So, well, so this is sufficient, right? Because we know that y is less than negative 2, which means that the answer to this question is a definite yes. All right, let's see if anybody out there in the peanut gallery can answer this question that someone just posted. Someone asks this. So chat box, what's the answer to that? Yeah, the answer to that is addition and subtraction you can always do, right? The thing that you're thinking about is when you multiply or divide things. That's when the whole sign flip thing might happen. But you can always do addition or subtraction in inequality. You know, I mean, just think about, you know, inequalities in real life, and it will be obvious why this works. I mean, like if I weigh more than my brother, you know, then if we both lose like 20 pounds, then I'm still going to weigh more because we both lost the same amount of weight, right? So me minus 2, it's not going to suddenly flip. And I mean, no matter what you add or subtract from our body weights, I'm still gonna weigh more. So it's like that. let's see, when canceling 8, no, Kevin, this is a step. I'm adding y to both sides of this. So there's 2 things going on here. I'm crossing off the 8, and then I'm adding a y to both sides. All right, statement 2, you can do the same kind of deal. So if x plus 20 is greater than 10, is x plus 20 greater than x minus 20? So that you can kill the x's. I mean, well, you can kill the x's. So look what you get. You get a question that says, is 20 greater than negative 20? Well, sure it is. So also sufficient. So they're both sufficient, and the answer is D overall. You can always perform subtraction on inequalities. As long as you are subtracting the same thing from both sides, you could always do subtraction. It's always a thing. So there's the strategy guide, by the way. Actually, this sounds like a foundations of math type of thing. Check out the intro to inequalities in the foundations of math book, and all of these questions will be answered there. Seems like you just need to brush up on that or remind yourself of how those things work. So that's a good place to do it. Any other questions about this problem? A couple people appear to be typing. So go ahead and type if you are typing. Try to hurry up so that we can do a couple more of these things. Up for GMAT 1, it looks like there's some typos there. X and Y could be, I don't know what that's supposed to say. I still don't know what BT, X, and Y is. Let's see, I mean the signs. Is the inequality different? MISC 1, 2, 3, I'm not sure what you are asking here. I mean, up for GMAT 1, I mean, like I said, you can always do subtraction in inequalities. I mean, if you're asking, can I subtract blah from other blah, the answer is yes, you can. You can do it. It's a thing. It doesn't matter what the circumstances are. MISC 1, 2, 3, I'm not sure what you mean by is it different from what. So maybe you could type a more detailed question or something. But let's take a look at see another problem. How about this? Go for it. This one's a word problem, so allow a little bit more time for it. So say I don't know, 2.5 or so. Go for it. And don't forget where the multiple choice answers are located. There they are. Okay, there's still a lot of non-answers to this, so please pick something that is a thing in the next like 10 or 15 seconds. Thanks. All right, ladies and gentlemen, here are your. There's still one person picking C here. It's always the thing. Remember the theme of today is that C is crap on these things, and I'm not going to suddenly go reverse psychology on you here. Okay, so let's have a quick discussion of answer choice C here before we talk about how to actually solve this thing. So, I mean, the thing you need to realize, and there's a lot of words in this problem, but the thing you need to realize when you first walk through the problem is that this plus this is Z is just the sum of X and Y, because you combine X tons with Y tons to get Z tons. So Z is not really a thing. Like, Z is just X plus Y. So if you pick C here, then I mean the easiness, well, ladies and gentlemen, you'd have Y as 10, and you'd have X plus Y as 16. So you can get X as 6. It's pretty freaking easy, right? There's no work to do. It's just like first grade arithmetic. Is it too much information? Well, yeah, you're handed everything. And you definitely don't use the key concept. If you do this, then the whole percent and averages are totally just not things. Like you don't even, you can ignore absolutely everything they tell you about percents and mixtures. So as soon as you look at this problem, you should be like, it's not C. And therefore it's also not E for the same sort of track. So we're looking at something that is either going to be A, B, or D. So any questions about this, feel free to chat them, but hopefully this is starting to sink in what kind of trickery we're dealing with here. It's not really trickery. I mean, that's the other thing about this, is that they are not trying to be mean to people here. Like, they're not trying to stick their foot out, metaphorically speaking, and trip you. Because that's the other thing people are thinking, oh, they're playing games with me. They're not really playing games. So what they're trying to make sure you're doing here is focusing. I mean, they're not trying to trip you up. They're just trying to see whether you are paying attention to what the problem is actually asking you about. And if you are paying attention to that, then you will know, okay, this is a track answer. So let's take a look at how to actually solve the problem. Keeping in mind that if we wind up with C or E, then we should be highly suspicious of that. So, all right, well, it's 10%. So percents, it helps to set up a table. In the case of any percent of anything, it's always percent times the whole amount equals the amount of the component. So percent of, we're looking at percent gravel. Percent gravel times entire mixture is going to equal amount of gravel. And then we have this for X, and we have this for Y, and then we have this for Z, which is really just X and Y combined. Okay. So X is 10% gravel, Y is 2% gravel, and together they are 5%. And then, yeah. Okay. And then the mixture weights are X, and that's what the X and the Y are. So, this is going to sound like a stupid question, perhaps. How many charts should we make that look like this? We can chat that. Should make, someone says 3. Any other ideas? Like, how many times should we physically make that chart? Just once? Twice? 3 times? 2 times. Ramiro. Y twice. Ramiro and Z. Why do you want to make it twice? You do want to make it twice. That's where I'm going with this. Why? Yeah, because there's two statements, right? So like, here's another useful principle. If you make a chart on a data sufficiency problem, then you should make the chart twice. Because remember that a data sufficiency problem is not a problem. It's actually two problems. You know, anytime you have any data sufficiency problem, it's because you have the problem with statement 1, which is like a problem. But then you have the problem with statement 2, which in effect is a completely separate problem. So when you have a chart on a data sufficiency problem, you should make 2 copies of the chart, 1 for each statement. You don't need a third copy. Maria, maybe you were saying third copy in case you wanted to combine them. But if you combine them, you don't need a third chart because you could just take one of the 2 that you've already made and just import the information from the other one into it. So you're not going to need a third chart. If there were a third totally separate statement, then you'd want a third chart. But combining things, you can just add on to your existing information. So, okay. In statement 1, we know that Y is 10 pounds, 10 tons. So that means that the gravel weight is 0.2 of a ton. And so then X is X, and so that is 10% gravel. So, and if you add, these add up, right? This is combined weight, so that's X plus 10 tons. Tons, if you're tons spelled like that, if you're from England. And you can also add these. So 0.10x plus 0.2. And that's an equation, right? If you look at this last line of the chart, that's something you can solve. I mean, that's an actual math equation. I mean, you might want to write it out and take it far enough to make sure that you can solve it. You don't just want to take one glance at it and be like, la, 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 la. But as soon as you realize that this is an algebraic, linear equation that you can just solve, then you should quit, just so that you're not wasting time. But let's at least write the equation down that you get. So you get 0.5, 5 times x plus 10 equals 0.10x plus 0.2. I mean, at this point, you can see that the x's will not cancel for x. And that means that you are, I don't know why there's a 3 there. It means that it's sufficient because you need a single value of x. So any questions about that, feel free. Statement 2, we can proceed in largely the same way. This time we know that it's, 16 tons total. Which means that this is x, and so we don't need the letter y anymore. Because if it's x and then it's a total of 16 tons, then what's the other one? Like how many tons is that? $16, yeah, it's take away, right? Subtraction. So 16 take away x tons. Remember, try not to mess around with variables that you don't need. So this is 0.10x tons again. This is now 0.32 minus 0.02x tons, and this is 0.05 times 16. So there's an equation, you can solve that. It's going to be the same sort of deal that happened with the first statement. So we have points, except now we're looking at the y line. So if we have that, then 0.02. Sorry, that's what we used to make that entry. But now we can look at this column. We haven't used that yet. So 0.10x plus that other thing has to equal 0.8. And we can solve this. So that's sufficient. So this is also D like dog. Isn't it quicker to solve by knowing it's a 2 by 2 equation? What do you mean by a 2 by 2 equation? Maybe depending on what that means. If you're assuming that anytime you get two equations in two variables that you can automatically solve that, then you are in for a world of pain and hurt. Because in data sufficiency, if you are presented with a system of two equations in two variables, then it's almost certainly not going to work like that. So you want to be very careful with that. More generally, you want to do the work, at least to the point where you actually verify whether things work or not. I mean, yeah, that's still a thing, but I mean, you shouldn't make assumptions about how algebra is going to turn out. Is basically the deal. There are plenty of systems of two equations and two unknowns where actually only one of them will solve the whole thing, and there are also plenty of instances where both of them together won't solve it. So basically, when it comes to any sort of guessing that something will work, you shouldn't do it unless you just don't have any time left at all. Because you should, that's what they do in data sufficiency. They make things that look like they're going to work but don't. Or they make things that don't look like they're going to work but do. So don't put yourself in a guessing situation unless you just don't have time. Okay. We'll start wrapping up here, starting to spill over the time limit. So thank you for attending. What I want to give you here as a, if I have it, okay, let me see if I have it. Hold on just a second, please. If I can find it, I might have a little surprise for you guys. Depending on where I can find it. Always a difficult thing for me. All right, here we go. What I've got for you guys is a little, it has a little lagniappe at the end of the session here. There's that word. If you don't know what that is, you can look it up. It's a Cajun thing. Here's a list of problems from 12th edition OG that are C-traps. It's a partial list. It's not all of the C-traps in the entire thing, but it's a list. What I want you to notice about this list is that there are a lot of problems in it. That's the thing I want you to notice here. Like, look how many of these there are. I mean, this is taken from, what, 60 or so problems. Out of 60 problems in the OG12 here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12. Like, that's fully 20% of all of those problems are C-traps. So, I mean, when it comes to the importance of this kind of thing, you really cannot overestimate it. Because, I mean, remember how this test works, right? It's an adaptive test that, uses the so-called difficulty level of the problem. Remember that difficulty level is not really difficulty level. I mean, it's really just how many people get it wrong. And a lot of the problems that are, ranked higher in their little difficulty scale are things that are not difficult, but that people just fall into the traps and pick the trap answer. So a lot of these are there, especially if you are scoring well on this exam. Like, the better you're doing on this exam, the more likely it is that you're going to see these C traps. So, because again, that's a big part of how they make answers supposedly more difficult, is they include these kinds of traps. So check this list out, go through these, and make sure that before you solve them, make sure you understand why they are C traps. Like, make sure you understand what aspect of them make them traps. If you don't have the 12th edition OG, I believe our website has some conversion tables somewhere to convert these to 13th edition problem numbers. So there it is. Okay, definitely out of time at this point, so let's start wrapping stuff up. And again, take a look at these as a parting gift. And we will see you guys, I believe, just 2 weeks is the next session here. So thank you for attending. And if you have any quick administrative questions, feel free. If not, then good night and good luck.